Good afternoon, everyone. I'd like to start off with land acknowledgement. The University of Alberta, its buildings, labs, research stations are all on native land that belongs to the territory of the Cree, the Blackfoot, the Métis, the Stoney, the Dene, the Iroquois, the Abenaki, and the Inuit nations. And we acknowledge the systems and cultures of all of the First Nations. My name is Catherine Field, and I'm a professor in agriculture, food, and nutritional sciences in the Faculty of AILS. And I'd like to welcome you all here. We have people in the room, and we also have about the same number of people, I think, right now watching live on Zoom. So welcome to everyone who is coming in via Zoom. I'm a professor, as well as I also hold a CRC chair in human nutrition and metabolism at this university. What I'd like to sort of go over today is first a little bit about the presentation. Today's presentation is going to last about 35 minutes, and we're going to have lots of time at the end for questions. So I encourage you to think up your questions and be ready to engage in discussion. Those of you on Zoom, if you could just type them into the chat, we will be monitoring those and we will be trying to integrate those questions as well into the discussion. If you don't know where the washrooms are here, if you go out this hall to the end of the hall, they're just on your left. So feel free if you need to leave. There's refreshments at the back, so you can jump up and help yourself. There'll be more refreshments at the end of the presentation. I was one of the committee members for this lectureship. This is the annual Ronald Ball lectureship. And this was set up, we're trying to figure out exactly when. I remember the first one I went to was in 2015, but I believe that there were ones before that. Dr. Ball is a professor emeritus at the university in the Faculty of AILS, and he endowed this chair so that we could have an annual lectureship that would be of interest to alumni, to professors, to students, to agronomists, to everyone in our larger university community. And the idea was that we would be able to have the opportunity to raise questions about current issues in the field of food, nutrition, and agriculture. Ron and Ruth Ball are really enthusiastic contributors both to the selection of the speaker as well as to this whole event. Unfortunately, Ron is a little under the weather today, so he's not here in person, and this may be the first time that they're not here in person, but they are on Zoom. And I know that Ron will be probably putting in into the chat right now some questions and some comments. So you will hear from him probably through questions that he might raise. This lectureship's been, as I said, going for a number of years, and we've had a lot of really eminent speakers come to the university, and it's a wonderful opportunity for us to bring in somebody from outside of our U of A community to talk to us. So I am going to now turn over the introduction of our speaker to our dean, Dr. Ricky Yatta. Dr. Yatta became the dean of our faculty in October, and he has survived the first 5 months of, I have to say, one of the colder winters in the past few years. He came from 2 years of being the dean, 2 terms of being the dean at the University of British Columbia in the Faculty of Land and Food Environment Sciences. So he is familiar with the areas of our faculty, but perhaps Edmonton is a new challenge. So I am going to turn this over to Dr. Yatta to introduce our speaker, and again, I'll come back to you when we come to the questions. So, Dean Yatta.
Well, thank you, Catherine. And I think survive was the right word. It's a little bit different from Vancouver. It made wearing shorts a little bit challenging this winter. I think I did stop wearing shorts when it became minus 25. So fortunately, the brain does cut in once in a while. But thank you all for attending Ron's lecture series. You know, this is a bit of a homecoming because Ron and I go back to our days at the University of Guelph. And in fact, Ron was just across the alley from where I was. I'm a food scientist by training, and the animal science nutrition department was just right across the parking lot, and we'd see each other probably as we parked our car and then as I traversed the animal science nutrition building. So Ron, it's wonderful for you to support this event, but I'm sad that you're not here in person, but I'll hopefully connect with you online. But thank you so much, Ron and Ruth, for your sponsorship of this lectureship series. You know, we have today William Cheung. William and I go back. I think, William, I met you, I think, in my early days of being dean because, and I'll read some of the awards, because William was getting an award at a dinner that I attended. And I had never met William, but as it turns out, William's department is just down the street from where Land and Food Systems is. So good to see you, William, and thank you. You know, it's fortunate enough for us to have William here because this month is this UN Sustainability Development Goals Month. And for those of you who aren't familiar with the UN SDGs, there's about 17 of them. And I would argue that AILS, our faculty, could touch on all 17. But, you know, the ones that we really focus in on are zero hunger, good health and well-being, gender equity, and others. So it's wonderful to have William here during UN Sustainability Month. And I guess I'll do some promotion because the University of Alberta is ranked quite high in the world rankings on sustainability. I think we're number 6. And so, you know, being number 6 is great. It makes us want to be number 1. And so that's wonderful. So a little bit about William, and I could take the whole 35 minutes, really, reading William's CV, but he is professor and director of the Institute of Oceans and Fisheries at the University of British Columbia. He is a Canada Research Chair in Ocean Sustainability and Global Changes, and he studies at the nexus of food, climate, and biodiversity in the ocean. So you can see the overlap with AILS. He is a director of a large grant, network grant, solving the sustainability challenges at the food, climate, biodiversity nexus. And he is really a world-class, world-recognized researcher. Among his many awards, and I'm very familiar with the E.R. Stacy Memorial Fellowship because that's with NSERC, I believe. And, you know, NSERC is kind of the gold standard by which academics want to get some funding from. So he is the creme de la creme. He is also a prize winner of the Prix d'Excellence Award from the International Council of the Exploration of the Seas. He's also won the award for excellence in marine science. And the one thing I'll tell you about William is he knows how to have fun. So William and I attended COP28 in Dubai, and we were out for dinner with Catherine. I'll tell you, you know, many of us attended the sessions. At least we'll tell you that we attended the sessions. But William explored Dubai, and he and Catherine, I think, hit all the high points, which they asked me if I did that, and I go, oh, no. I kind of went to the sessions, maybe. I went to the mall. The malls in Dubai are just incredibly large. You can get lost in them. So that was my claim to fame. The other thing that I'll let you know before I turn it over to William, he's been named one of the top 20 world's most influential climate scientists. So he comes to us with great credibility and great reputation. So with that in mind, William, I'm going to turn it over to you, and we're so happy that you could join us, and we're so happy we could turn the thermostat up so that it wasn't minus 25 for you during your visit. So, William, over to you.
Thank you so much. Thank you, Catherine, and thank you, Vicky, for the introductions. And also thank you for the faculty to invite me to come to speak in this lecture series. It's an honor to be here, and I hope that I will get to meet Professor Bo one day, although unfortunately he couldn't be here in person. Also, I want to thank and acknowledge the generous provisions of the land by the First Nations and the Métis people for allowing me to speak in here to talk about the topic related to something that I feel really passionate about, and that I think it is an important topic to discuss, which is about climate change, and particularly climate change effects in the oceans and how that affects people through fisheries and aquaculture. So I will start my talk from a place that is in this photo. You may not recognize where this place is. This is Hong Kong, and I think most of you who have any imaginations about Hong Kong or haven't been to Hong Kong have the picture that Hong Kong is full of high-rises, densely populated area. But many areas in the Hong Kong are actually places like this. And I grew up in a place like this, in a village that is on the top, a little bit left-hand side of the coast. So I grew up in the coast. I was really connected to the oceans, and particularly I remember fondly about the stories that my parents, particularly my fathers, my uncles, told me when they were young. They go out, they went out fishing just by the village, along the coast by the village, and that they caught a lot of seafood that would be sufficient to provide a good meal for the different families in the village. But then when I grew up, I didn't see them going out fishing anymore. And one of the reasons why they told me is that there wasn't any much seafood anymore along the coast for them to catch. But that really drew me into the interest of understanding the oceans, as well as understanding why there's such a changes in the oceans, from abundant marine life to something that is become so rare that my parents, my uncles stopped going out to go fishing. But I still grew up with eating a lot of seafood. That this is part of the cultures in Hong Kong. And when I grew up, these are the fishes that I normally had on a normal day dinner. My moms would go to the market, get fish almost every day. It is one of the cheapest source of protein available at that time. We could get the threadfin beam or yellow croaker or the four-finger threadfin, really at a really lot expensive price, affordable. This, I think, is one main source of protein and meat for us in the family. But nowadays, these fishes are becoming rare and rarer. For example, for the large yellow croaker is so rare that you cannot get that normally in the fish market nowadays, wild caught. You can still see a lot of the large yellow croaker on the market, but they are all from fish farms. And the price is outrageous. You have to pay $100 for a fish that is much smaller than what we used to have for a large yellow croaker. And part of it is because of that the fish are now getting very rare in the South China Sea, where they used to be really abundant. So it prompted me to ask the questions. I saw the changes from my parents' generations to my generations, and also that I'm now seeing the changes in my own experience. I'm now wondering what oceans future will my nephews see when they grow up in the future. I don't have children, but I have two nephews, and that's my sister and that's my two nephews on a weekend trip to the coast. And it is not the coast that we used to see anymore. It is largely transformed with seawall, and you also see a lot of abandoned nets from various sources on where they are standing right now. But is it something that we want them to experience when they grow up or when their children grow up? So these are the things that I want to highlight in my talk. So first of all, I will give you a brief overview of the global status of fisheries and aquaculture so that you have that as a context when you understand how climate change on top of that is affecting fish and fisheries now and in the future. And then I will go into the more details about climate change. And particularly, I will talk about the effects of some of the things that we are already seeing through extreme events, through compound events that are affecting fish and fisheries and aquaculture. And then I also mention something that can have very big impacts, even though they are not very likely to happen. And at the end, I will talk about something that would allow us to go to a future where perhaps I want my nephews to grow up in, and how we can bend the curve from what we are heading into to something that is more desirable, more sustainable for the oceans. This is a picture showing the interconnections between the oceans, marine ecosystems, and people. The ocean is really important in modeling our climate. It absorbs more than 90% of the heat, more than 20% of carbon dioxide that we emitted. So without the oceans, climate change will be even worse. And the ocean is also supporting diverse marine life and ecosystems that many peoples are dependent on for food, for livelihood, and for their culture. But we know that in many cases that we are also overutilizing the resources, having human impacts on marine ecosystems, affecting both the biodiversity, ecosystem functions, and ultimately also affects the ability of the oceans to moderate our climate as well. And these changes are also affecting the oceans in supporting other services to human societies, particularly in the case of fish and seafood to people. This is a figure showing the global production of seafood from the ocean, from captured fisheries. Since the 1950s, there has been a rapid increase in global fisheries production until the 1990s, where we reached peak fish, or the peak of the fisheries catches, and since then, global fisheries catch declined, even though the importance of artisanal and subsistence fisheries continue to increase, meaning that those fish that are most likely to go to the dinner table or the meal table of many of the coastal communities. From the other side, we also see a continuous and exponential increase in our intensity of fishing, so measured as what we call fishing efforts, the amount of input that we get into the sea to try to catch the fish. This is through increasing the number of boats, increasing technology, such as engine powers and other technological inputs to catch the fish. And particularly in the last few decades, fishing efforts continue to increase, but catches do not increase. This means that the catch per unit effort, which fishery scientists use as an indication of fish abundance, actually is declining. And this is a sign of overfishing. We've heard about the importance of fish farming or aquaculture, or in the oceans we call it mariculture. Mariculture expanded really rapidly in the last few decades. However, it is still a small proportion relative to global seafood production from captured fisheries, and that it also has its own sustainability challenges. And all of these have an impact on the fish stocks and ecosystem. And it is shown up in the number of overexploited fish stocks, where it is continuous to increase since the 1950s. And that for different metrics of biodiversity. In this case, that is called the Red List Index, which is used to measure the number of species that are being endangered by human activities. it is actually increasing, and most of it is driven by overexploitation as well. So overexploitation leads to decrease in resource abundance, increasing number of fisheries that are overexploited, while also reducing the biodiversity, leading to biodiversity losses in the world. But our science has progressed. We actually know how to deal with these challenges. We know that by reducing fishing effort, by protecting the ocean, for example, through protected area, we can restore depleted ecosystems. We can manage fish sustainably. For example, this picture shows the perceived or the potential biodiversity and ecosystems through different level of protection of the oceans. And there are a lot of evidence in supporting this picture. The challenge is implementation, how to effectively implement this science and knowledge. And on top of that, climate change is actually adding additional challenges to sustainably manage fish stocks and fisheries and rebuilding ecosystems and biodiversity. With continuous increase in the amount of carbon dioxide and greenhouse gases that we get into the atmosphere, it is leading to continuous ocean changes, including ocean warming, deoxygenations, ocean acidifications, that then affects ecosystems and the services that ecosystems deliver to human society. And these changes have already been occurring in the oceans. This is a figure from the Intergovernmental Panel on Climate Change, including both observational data as well as projections from global Earth and ocean models. It basically shows that the oceans has been increasing in temperature, increasing in acidity, decreasing in oxygen, increasing sea levels, and that these changes will continue, particularly under a high emission scenario, as shown by the red line there. So in the future, the amount of emissions or the ability to mitigate climate change is really important in determining what level of ocean changes would be in the next few decades towards the end of this century. And these changes have direct impacts on marine life, particularly on fish and invertebrates that are so important for us as source of seafood. Fish and invertebrates, they are ectotherms, so their body temperature is dependent on environmental temperature. And we know that their body functions would operate well within a certain range of temperature. And when temperature becomes too hot or too cold, the body functions decrease. And at some point, if temperature becomes extreme and sustained for a long time, they will die. And other changes in ocean conditions, such as deoxygenations, acidifications, it exacerbates that impact as well. But many species are able to adjust or respond to these changes in the oceans through changes in their biogeography or distribution. So for example, imagine the red circle is the distributions of the fish stocks. And under ocean warming or deoxygenations, the fish can shift their distribution. And in general, with scientific evidence from historical observations as well as theoretical projections, we know that species tends to shift to high latitude regions or deeper water, where they can find area where they can maintain their environmental conditions or temperature, even though ocean continue to warm up. But these changes can have consequences on ecosystems and fisheries. For example, the changes can alter the interaction between species. It can also alter the interactions for fisheries between target species, the species that are important to fishing, as well as non-target species, those species that we don't want to catch, such as sea turtle or dolphins. And so those interactions can be affected by this shift in distributions of the species. At the same time, it affects the effectiveness of conservation measures. Imagine that we have a conservation area that is designed to protect these tuna species. Now the shift in distributions away from this protected area really affect the effectiveness of the protected areas in conserving the tuna in this particular example. At the same time, species shifts can actually affect international politics. We've already seen that. Species that change of distributions can shift across political boundary. Fish do not need a visa to cross the border between two countries. So in this case, country A can gain the resources while country B can lose it. And that can generate international dispute in co-management or sharing of resources. And these changes can also interact with other emerging human activities, such as deep sea mining or other activities that can have effects or interactions with species. At the same time, the ocean productivities will be also affected by climate change. And one of the main sources of ocean productivity is through phytoplankton, which is the micro octotroph or photosynthetic organisms that generate the energy from photosynthesis that support the whole trophic food web of the ecosystems, of the marine ecosystem. And we already know that climate change will affect primary production through changes in temperature, through changes in the distributions and availability of nutrients to support phytoplankton growth. And recent study shows that there seems to be a decrease in overall net primary productions in the oceans in recent decades, although projections for the future is still very uncertain. Different climate models and ocean models project different changes in ocean primary productivity. But we know that there will be changes, but we just don't know what the changes will be. And these changes are affecting fisheries, affecting the types of fish and the amount of fish that we are getting through capture fisheries. And we are already seeing that in our fishery catch record. This is a study that we did looking at global fisheries catch record in the last few decades, since the 1970s. And in this analysis, we look at the catch compositions of different fisheries around the world. What we find is that increasingly, fisheries are catching more and more of a warmer water species, which is depicted by the red colored fish there, while the cold color fish, the cold dominant fish, the blue color fish are getting less relative to the warm water species. There are also differences in the changes between regions. In tropical regions, like in here or in the Arctic, there is what we call the tropicalization of fisheries catch, where fisheries catches more and more of a warm water catch species. But in the tropics, we find that species compositions are actually losing their diversity, with species that cannot tolerate the warmer waters, reducing in the dominance in the fisheries catch, while catches become increasing dominance by those that can resist the higher temperature in the tropical ocean. And that shows up in the index here. In the index here, where what we call the mean temperature of the catch, that is the average preferred temperature of the fisheries catches, weighted by the amount of the weight of the fish in each year in each location. So the more catches that is warm water preferred, the higher is the mean temperature of the catch. And we see a continuous increase that is related to sea surface temperature in extratropical region, while in tropical area, you see an initial decrease and then leveling off because the species are basically dominated by those species that can sustain and resist the high temperatures in the tropical ocean. We also make projections of the future using mathematical model, combined with scenarios about what the future change would be, including climate change as well as societal changes. And I'm going to show you a few of these projections illustrating what the future oceans may look like with increasing climate change. This is a projection that focuses on the compositions of the species, or the diversity of fish species that are important to fisheries catches. In this case, the left-hand side of the figure shows the average changes in the species gain and loss. If you look at the map of species loss, there's a big area along the tropical area, and that's because species are shifting away from the tropics as ocean temperature increases and other ocean changes that exacerbate that. That leads to a net loss in the number of species in those tropical oceans. While, as you expect, there are increasing species gain in high latitude area as the species shift to high latitude region. And that really challenged both the ecosystems as well as the fisheries. And that's matched up with what we have been seeing in fisheries catches in the last few decades. At the same time, when we look at then the total productions of biomass in the oceans, we measure it as the potential fisheries catches or maximum catch potential from the oceans that can support fisheries. We showed a decrease in potential fisheries catches as climate change continued to intensify. And we indicate the level of climate change through global warming level. Right now, we are almost at 1.5 degrees Celsius warming relative to the pre-industrial level, which is indicated by the orange bar there. But then if we continue to let our world to warm up by increasing greenhouse gas emissions, we're expecting to see continuous decrease in catches, global catches, because of temperature changes, because of also a net decrease in net prime productions in the world ocean. Well, you may think that maybe you can farm more fish if we catch less fish from the ocean. But aquaculture will also be affected because the way we farm our fish is that it's still highly dependent on the environmental condition. If you have been to or seen a salmon farm, you know that we put salmon in a net where it's immersed in the water, which is exactly the same as the wild salmon living in the water. So warming water, more acidic waters will still affect salmon growing in the net cage. And that is the same for most of the shellfish farm as well. So if we use our mathematical models to apply to aquaculture, we also find that aquaculture will be affected by climate change. For example, this is a comparisons between different time periods and different climate scenario for global aggregated aquaculture production from the ocean. We projected a decrease and even a loss of aquaculture production potentials compared to a low emission scenario in the later half of this century. So which means that we know capture fisheries potential will decrease with climate change, but that aquaculture potential productions will also decrease as well. So with that picture in mind, we also need to know that one of the aspects of climate change impact of the ocean, and it is the same as other climate change impacts in the world, that not everyone is impacted equally. Some people are affected more than the others. And particularly, there are coastal communities in the world that are really dependent on seafood for their well-being and for their nutritional health. This is a picture that I took from Ghana, which is one of the case study in the partnership projects that Ricky mentioned. And these are the fish landing sites, and the picture is the mooring when a lot of small coastal fishing vessels trying to land their fish, and many of those fish, again, will go to the dinner or meal tables of the coastal communities. And this is not only in Ghana, but in many parts of the world. Seafood, they are really dependent on seafood as a source of nutrients, protein, omega fatty acids, zinc, iron, calcium, as indicated by the blue color in the map. And many of those areas are also area where they don't have a lot of other options to get those nutrients other than seafood. But when we map these figures of nutrients dependence on top of our projections of future changes in fisheries and aquaculture under climate change, sadly, they match closely between high dependence countries for seafood as nutrient sources and those ocean regions where we project a large loss in potential seafood production from fisheries and aquaculture, as highlighted by the red color there, like in Southeast Asia, in West Africa, or in some part of South America. And it is not that high latitude countries are all safe from these changes. We know that even in Canada, there are some coastal communities that are really dependent on seafood for their nutritional health, for their culture, such as a coastal First Nation in British Columbia. In our project, in our partnership, one of the case study is in British Columbia, working with the coastal First Nation there. And these are projections from our mathematical models. We show them that with climate change, many of the species that are important for them as a main seafood, which we know that are important seafood for their nutritional health, are also projected to decrease, including salmon, including herring, including halibut. And right now, many of these coastal First Nations are already facing serious food insecurity. And so these changes are expected to exacerbate those food insecurity. So one of these poems provide a really good reason why they need to start thinking about climate adaptations, trying to think about how they can secure the seafood for their future. And again, we know a lot of science about climate adaptation to some of these changes. And the good thing is that we know that good fisheries management, good conservations are also good climate adaptation strategies. So for example, sustainable fisheries management, protected areas, they can also contribute to building up adaptive capacity for coastal community and for the ecosystems to adapt to some of these changes that I just talked about. And this is a figure that is based on the IPCC and highlighting many of these coastal solutions that are supporting sustainable development of the oceans are also good climate adaptation strategies. They are effective. They have proven that they can be beneficial to support climate adaptations, and that they are feasible as well. But on top of these long-term changes, many of these solutions and many of the coastal communities are also facing immediate impacts through extremes and compound events. This is a picture that I think is quite remarkable, that shows the heat waves that are hitting the North Pacific regions a few years ago. You see the red color showing an area with abnormal temperature, up to 5 degrees Celsius higher than normal temperature during those heat wave period. And that's a long heat wave, 2 years. And one of the examples of how those heat extreme events can affect fisheries and coastal communities can be illustrated by the Alaskan king crab fisheries. It is a remarkably valuable fisheries, multi-billion-dollar fisheries. But the US government closed it down a couple of years ago because of the heat waves. And they find that suddenly they couldn't find any crab in Bering Sea. So they have to close down the fishery. And that's recent science that shows that the disappearance of the king crab, of the Alaskan crab, is because of the heat wave that they experienced from 2019 to 2021. And there are solid scientific evidence that shows that during that period, crab density decreased after the heat waves, and that's because there are two reasons. The high temperatures actually kill a lot of the juvenile crab, and secondly, it also reduced the availability of prey for the crab. So with that, it really affects the abundance and density of crab, and that you see there's also a gradual shift of the distributions of crab towards more northern Bering Sea as well. So the fisheries are struggling to find crab where they used to find fish in the Bering Sea, and the government had to shut down the fisheries. They just had a limited reopening of the fisheries, but many of the fisheries still struggle to recover from that closure. And our mathematical models actually shows that these changes are not only unique to crab, but that many species will have similar responses when they are faced with heat waves. So this is a simulation modeling output that shows that a more variety of distant species are projected to, in the Northeast Pacific regions, are projected to decrease in biomass, as well as change the distributions when a heat extremes events occur. Again, fisheries management can actually help with moderating these impacts. This is a simulation modeling exercise to explore the scenarios of with good fisheries management and without fisheries management. And in this case, we applied that to the California sardine. What it shows is that if you look at the x-axis, which is the population abundance, you see that on the left-hand side, without fisheries management, it actually leads to the collapse of the anchovy fisheries, where because of the heat waves, it drives down the anchovy abundance. And without good fisheries management, it exacerbates that impacts, actually leading to the collapse of the anchovy fisheries. But if we have good management, where we use science to detect when there are high impacts of heat waves on anchovy and manage the fishery accordingly, it can maintain high fish abundance while allowing continuous productions of the anchovy fisheries, even though we have to close down the fisheries during the years when there are big impacts of heat wave on the anchovy fisheries. So what this shows is that good fisheries management was still applied in the case of adapting to heat waves, but that it required knowledge, it required data, it required monitoring in order to inform the more adaptive fisheries management to these extreme events. So finally, I want to talk about these types of event, which is we call high impacts but low probability events. I don't know how many of you have watched this movie. This is not not a particularly good movie, but it shows a exaggerated picture of one of these events that I'm going to talk about. In the movie, it shows that suddenly the North Atlantic climate switch, and the east coast of the U.S. suddenly becomes really cold with a surge of sea level and things like that in one day. And that primarily is it relates to a big important oceanographic features, which is called the Atlantic Meridional Overturning Circulation, or AMOC. In simple terms, basically these AMOC ocean current systems bring warm water from the tropics to the North Atlantic, and then the warm water sink to become cold water, and then again bring the cold water down to the south, to Antarctica, to southern oceans, and then the waters bring the heat up back to the north. And that's primarily the reason why Europe is at a moderate temperature compared to its latitude. So without AMOC, the Europe will be actually very, very cold. But there are already signs of slowing down of the AMOC with increasing climate change. And you can see that with the blue color on the oceans in the North Atlantic there, that's from observations. We have been seeing a gradual cooling of that ocean area in the past few decades. And that's related to the slowing down of the AMOC. And that's related to increasing cold water and fresh water from melting Arctic sea ice and the Greenland glacier, as well as warming of the tropical water. But these events, there is a chance, although very low, that the AMOC can be collapsed. So it can stop because of increasing global warming, more warm waters, more melting of ice. And this picture shows that extreme scenario. This is a computer simulations with doubling of carbon dioxide concentrations and the total collapse of the AMOC. So you see that the whole North Atlantic area, including Europe, becomes very cold compared to the rest of the world, which is much hotter. But this event, in the scientific consensus, is that it is not likely, but we cannot rule out that it would not happen. So that's basically the consensus. But even if it happens, it would take decades to centuries for the collapse to happen. So it's not like in the movie, just one day. It would take a long time. It is fast in the geographical or oceanographical time frame, but not in a day's time frame. And that would have a big impact, or if that happened, that would have a lots of consequences on fisheries, because the changes in temperatures will affect the distribution of the species. It will affect the deep water ecosystems, because it will reduce the amount of oxygen that would go into deeper water. It would affect ocean primary productions, because the AMOC also bring nutrients around the world. So without AMOC, it would affect the distributions of nutrients, and that affects primary production. And we talk about that primary productions directly affects amount of fish production. It affects regional fisheries productions, because it affects monsoon. Monsoon really directly relate to regional fisheries productivity. And then it will lead to sea level rise, particularly in the east coast of North America. And that affects a lot of the coastal ecosystem and infrastructure that are important for fisheries as well. And the most effective way of preventing the collapse of AMOC is actually staying away from the potential tipping points that would drive AMOC collapse, which is by reducing carbon dioxide emission. So, looking at the future, we have depicted the business of usual, business as usual scenario that we are going. That is not a scenario that I want my nephews to go to. And the alternative is to bend the curve, to go to something that is much more desirable and much more sustainable. It required a lot of societal changes, both increasing, conserving the biodiversity, also reducing inequity, supporting management, and some of the specific interventions that I talk about, including the effective implementations of some of the marine and coastal nature-based solutions, effective science, particularly through monitoring, precautionary applications of ecosystem-based management, and also, most importantly, mitigations of climate change, because many of these solutions will become ineffective if we allow climate change to continue to intensify, particularly under a high-emission scenario. And we know that many of these broad strategies required understanding of the local context in order to provide the optimal solutions, options for local communities, for local areas. And that's why we developed these international partnerships to solving sustainability challenges at the food, climate, and biodiversity nexus. And in these partnership projects, we have different case studies to illustrate how different contexts in different areas of the world really would require a different set of options to reverse, to bend the curve. And that how different experience and different knowledge from different parts of the world can also help support each other. This cross-experience learning and cross-knowledge transfer would help also support the development of solution options. So, I'm still exploring these questions about the future of the oceans for my nephews. And definitely one thing that I'm sure is that I want them to inherit an oceans that is both diverse and productive, and that it is something that something that myself and my parents and my grandparents have experienced, and that they have the options to actually enjoy that oceans, and then they can decide how they want to continue to conserve and use them. So with that, thank you so much. Yes. Yes. Yes.
Thank you, William. That was amazing. I wonder what type of information, in your experience, what type of information and research do we need to actually inform policy and to incorporate local adaptation strategies? What else do we need to improve this and to get that future that you want?
Yes, I think one important thing that is needed is to listen to what the local communities and people needs and wants, because we first of all need to set up a vision of and goals about what the future oceans they want to see, in order to develop a pathway that would allow them to achieve. So I think imagining what a sustainable and desirable oceans by the coastal communities and by the people there is an important first step, because it can be different from different area. Like in Costa Rica, they imagine a different picture of the oceans compared to people in China, where they look at the oceans from a different perspective. They can be both desirable and sustainable, but that they can also be a different perspective, whether there's more focus on nature or more focusing on the services of the ecosystems to people, or more focusing on the cultural part of the oceans, and that required the co-development of these visions with the coastal communities. We can provide the tools to help them to envision their future, but then it will require them to do the envisioning, and then the research and science can provide additional support to see how we can get there. What kind of options would allow them to reach there effectively? What are the barriers and what are the enabling factors, and how to actually put together those resources, both human resources as well as financial resources and scientific knowledge, in order to allow them to achieve that visions of the future. Thank you.
Thank you for your presentation. Dr. Cheung, I have a question about the decades of experiments that have shown orcas and other fish see the environment. We cannot. And you alluded to the movie The Day After Tomorrow, which is now 21 years old. But it does give us sort of a glance or a lens into what are the potentials and what are the risks. So I think my question is related to the idea that we are at a tipping point, and I'm just really curious as to how we could potentially look at policy, which we just answered, but when the federal government just refused an emergency order of the endangered southern orcas, 73 of them in the resident seas, I'm just curious, how can we relegate it to experience, and your experiments obviously would be telltale signs for us in the future.
Yes, that's really good questions. And I think I know there are, and particularly now in the current times, is quite demoralizing looking at both national and international policy arena, particularly in climate change, in also other environmental and sustainability related policies. But I think we also shouldn't give up on that as well, because I believe that ultimately the policies would need to reflect what the people want, and I sense that there is a strong demand for a more sustainable future, a better environment for both the animals as well as for people. And so I think we just need to, first of all, continue to communicate to the people, the public, about the changes that we are seeing, and then the benefits of actually doing good conservation, good resource management, good environmental policy can bring to us and to our next generation. I think that's important, and so that we can continue to maintain that demand and increase that demand, and ultimately that's kind of the driving force for changing policy. I believe that the politics will change over time, and there will be time that this momentum built by the people will be effective in driving transformations that would be necessary to overcome some of the things that we would in our science we project under a business as usual scenario.
Question here from Ron online. and that is that Danish and Dutch researchers have predicted that the AMOC will reach a tipping point within 50 years with a 95% probability. And what is your opinion of their research?
Thanks. So that particular studies use take a very unique and innovative approach. They use a data science approach. So they actually compile data and then look at historical properties of the data, and then use that to then make that predictions about the collapse of the AMOC. That it can happen by the mid 21st century. But that's not supported by a lot of the other ocean modeling, climate modeling, and things like that that do not show a high likelihood of that likelihood of AMOC collapse in their ocean models. And so what the consensus in general, as reflected in the IPCC assessment, is that there's a low likelihood of the collapse of AMOCs in the 21st century, although the possibility cannot be ruled out because of that. But the consensus is that it is still a unlikely event.
Thank you very much, Dr. Cheung. I have one curiosity-driven question. The other one is more mechanistic approach, how the aquatic ecologists deal with it. First one is, you mentioned that there's some fish species that moving upward latitude because of climate change. Are the scientific community consider them invasive species? That's number one. Number two is you mentioned several times sustainability, right? I'm a terrestrial ecologist. We focus on sustainability, not the species, really focus on the habitat, how we protect it. I don't know how this works in aquatic environment, but they are highly tied to I'm not sure you can really change the sea temperature or stop the acidification. I don't know, what options do you have under these conditions? Thank you.
Thanks. So the first question is about whether species shifting their range maybe to novel habitats, whether it's considered to be invasive species or not. I think there was academic debate about the use of the term invasive species, and I think the general, a lot of the literature are suggesting that maybe we should reserve the wording invasive species to really the traditional sense of invasive species, where it was it is an introduction of by human activities to become an alien species, and that as their populations become dominant, it becomes an invasive species that have a negative impact on the ecosystems, which I don't disagree. So we can use different terms, but the concept can be similar, where the expansion of the species to area where they haven't been to before can have similar consequences to ecosystems, where they can disrupt trophic interactions. It can have consequences on the habitats and things like that. So those properties for like traditional invasive species can be analogous to one another. And about the questions about sustainability, I think in this case, with climate change, a lot of the interventions that we use for ocean sustainability, like for example, as Ricky mentioned in the Sustainable Development Goals for 14, which is life underwater, is considered to be one of the ways to help adapt to climate change. Is part of the nature-based solutions through more effective fisheries management. And with that, it means that, for example, one of the drivers of overfishing is subsidies. And in capture fisheries, many governments are still subsidizing the fishing fleets so that they will continue fishing even though the fish stocks are overexploited. And so there is a big push to eliminate particularly the harmful subsidies that support overfishing. But still, I mean, in the WTO, it's still it's not conclusive. There are still a lot of loopholes to avoid that of reducing the subsidies. And then also setting up protected areas. I think in the oceans, there's the commitment for setting 30% of the ocean areas as a protected area, the 30 by 30 Montreal Quimbing Agreement. And so those are also specific strategies that can help achieve sustainable development in the oceans. But then also that relates to sustainable coastal communities as well. And a lot of the work that my colleagues and myself does shows that a lot of the barriers to ocean sustainability is actually from the human society, that it actually need to support sustainable development along the coast in order for those interventions to be able to effectively implemented. And for example, in some area, like protecting the oceans would not be viable because the coastal communities are still in poverty. They still need to go out fishing, and that dependent on the oceans, that they don't have alternative livelihood. So there are also those kind of sustainable development activities that needs to be done in order to have the oceans becomes part of the sustainable future. Thanks.
Thank you so much for the great presentation. As we all know, when it comes to the climate change, of course, the science section, it's always important. But in addition, public awareness is one of another approach in the climate change topic, as you already mentioned in some of your slides. So did you have any experience in your projects how you could simplify your scientific findings for the normal communities who are not specifically full academic people?
Yeah, that's important questions. And when we have projects that work with coastal communities, like for example, we work with coastal First Nations. So we present, they are very interested in knowing about the science, about what fish, particularly the seafood species that they are so rely on, would be like in the future under climate change. They want to know whether they still have salmon in the next few decades. So we actually talk with them about that. We have focus group discussions. We explain to them about some of the science through just talking with them in different community town hall meetings, and we don't need to present them with all the scientific details, but just focusing on the things that they want to know. And I think that's important, is that knowing what their interest is and what they see as important knowledge, and then focusing on providing them with easily understandable messages about those information that they want and they need is important, so that we don't have to give them a whole details of scientific research that would probably confuse them more than letting them communicating to them what they feel as important. So, for example, like I don't need to talk about all the oceanographic changes or the details of the mathematical models, but then focusing on like talking with them about the future of salmon, where they know a lot about, but then they also care about what the scientists say about those futures.
I have one more online here, and then I'll get one more in the back, and then we'll be done. So from online, do you see the SDGs and low emission scenarios as attainable through policy and collective action, or are they more something to aspire to but not likely to be reached in reality? Yeah,
it's definitely is something that is an important target to achieve. I think with the climate goal, like the goal under the Paris Agreement is to maintain global warming at or as much as possible below 1.5 degrees Celsius warming, and the possibility is getting lower and lower. But still, that is an important goal to see, and because it allows us to have a goal to design our policy, to design our actions. We don't, even though we over our global warming level will go over 1.5 degrees Celsius, we will overshoot it. But we want to get it as close as possible to the target, because we know that from our science, the further we go away from the 1.5 degrees Celsius, the more the risk of all the impacts that I mentioned, including the collapse of the AMOC. The risk of those events increase as global warming level continue to increase and beyond 1.5 degrees Celsius level. And that also allows us to think about how what we need to do when after we overshoot that. A lot of the latest science is also focusing on what we call the overshoot scenarios, where if we overshoot the 1.5 degrees Celsius target, what should we do? What will be the impact of the society, and how should we deal with those impacts, particularly the impacts on those vulnerable groups that will feel the impacts most, the low-income countries area, the vulnerable groups of the society. So I think still having those targets are really useful in helping us to think about what are the policies, both in getting close to the targets as well as how to return to closer to the targets after we've overshoot that.
Thank you. And here's the last one.
Thank you for your insights today. I'm wondering, what tangible steps can we take to enhance our global connectedness in addressing the issue of climate change on marine ecosystems?
Yeah, that's often a challenge. I think it's particularly a difficult challenge for the oceans, because we know that, for forests, we can see it, but for the oceans, for majority of the people, it is so remote that they don't feel the connections. And I think that's why the importance of ocean literacy is key in here, where we need to communicate and also transfer the knowledge about the oceans and highlight the connections of between the oceans and people. That is not something that is very remote. It's actually interconnected with all of us, even those living in landlocked countries. The inherent connections between the oceans and the importance of the oceans. And I think that's the first step of really making people realize that they actually need to take actions about the oceans. And then the next step is about what actions they need to take. And I think that there are very many different levels, and particularly with the general public. They support policies that would support sustainable oceans in terms of sustainable management of seafood, setting up protected areas to meet the 30 by 30 or protections of 30% of the oceans as a target, and things like that are important. As I mentioned, the demand by people in those policies really matters in really increasing the likelihood of an effective policy being in place. And for people along the coast, and particularly those that are being affected by these changes directly, such as coastal First Nations or coastal communities, they also need to think about what actions, adaptation actions, they want to see in order to adapt to some of these impacts. So, for example, in the nations that we work with along the coast of British Columbia, they are thinking about, our science and through their experience that salmon's population is declining. But then they are also increasingly see some of the warmer water species moving to the coast, and that are becoming more and more accessible to those communities. So they are actually thinking about maybe they should expand their fisheries to those new resources in order to substitute some of the traditional species that they are seeing declines. So they are running community workshop to introduce these new species to the harvester, so that they are prepared to make those changes when there's a need to shift the fisheries to expand the fisheries to those potentially newer resources under global warming. So I think those are the actions that local communities can do itself, even without the international policies, and those local action is really important because global actions are really a support by a lot of these local actions that can meet the global policies and particularly in terms of adaptation. Oh, thank you.
Okay, I have a couple thank yous before I thank Dr. Cheung. Just to thank Kathleen Shippett for helping, really organizing this event, and she's hiding in the corner with the microphone right now, and her team. And I'd also like to thank again Ron and Ruth Ball for endowing this lectureship, because I think we had a great one today. I'd like to thank you, Dr. Cheung, for this really stimulating lectureship. It's exactly what we wanted for this, this presentation. And I know as an omega-3 researcher, I learned an awful lot about the value of the oceans far beyond a source of omega-3s, and how we might be worked forward to try to save them. I'd like to thank everyone in this room for coming, and those of you on Zoom. This presentation has been recorded, and if you want to listen to it again or share it with anyone, you'll be able to access it through the on-demand at the University of Alberta. And Kathleen told me that she's also going to try to link it to the Ron Ball lectureship site. And so on that, I'd like to close this session, and there are more refreshments, and I hope that you stay and linger in the lobby and talk with your friends here. So thank you very much, Dr. Cheung.